Stoichiometry chart style, page number 9, problem 4. So we have a double displacement reaction, but it's not giving us the equation. So it looks like we have to review that and fill that in here. So I'm going to go right to that little marker. It says lead nitrate. So I'm going to write this formula for lead here. It's Pb. And I have nitrate, which is NO3. That 3 should be a subscript. And I'm going to put a 2 behind it. And here's why. It says lead 2, so lead has a charge of plus 2. I look on my common ion chart, nitrate is -1. So balancing the charges out, I say, oh, lead is plus 2 up here. This whole thing, NO3, is -1. So I need 2 things at -1 to balance one thing at plus 2. Notice these 3's and 2's should be a subscript, but in this mode, it's harder to do that. Okay, next thing is sodium iodide. It looks like Na is +1, I is -1. So I know that's balanced. So I'm just going to write NaI right there. I'm not going to put the +1, -1 because we know that balances right there. I think there's an arrow given, so I'm going to kind of keep going through here. What's one of our products the lead's going to combine with the iodide? I'm going to write PBI2, and that 2 again is a subscript. How do I know it's PBI2? Because lead we said was +2, and I we said was -1. So this is +2, this is -1. So 2 times -1 balances 1 times +2. So we write PBI2. That 2 is really a subscript. And then the last one is going to be sodium nitrate. And notice nitrate's -1, sodium's -1. So that's going to balance in a 1-to-1 ratio. And let me write that in here and say Na. I'm going to put the NO3 in parentheses. Na is +1, NO3 is -1, so that's balanced. We don't have to do anything else. In this case, because it's a 1-to-1 ratio, you wouldn't have to put the NO3 in parentheses, but I just think it makes it easier to see for balancing. For example, you have 2 groups of NO3 here, only 1 here, so I'm going to put a 2 out in front to balance the nitrate right here, or the NaNO3. And if I have 2 NAs, I got to put a 2 here. I got 2 NaIs, I got 2 Is. Well, I already have my 2 Is, and I got 1 lead and 1 lead. So these are 2's. There would be 1 coefficient in front of the other things. So there's my balanced equation. Then I see this 169 grams of lead iodide. Oh, that's not molar mass, that's not moles, that's right here. So I got to fill that in right here. And I'm going to call this 69.2 grams. And now we got to fill out all these different pieces with this one right here. I'm sorry. Let me be careful. I'm going to form 162 grams of lead iodide. So be careful. This would be 69.2 grams of lead iodide is formed. So I know this product, I can figure out this product, I can figure out my amount of reactants here. Okay, I think I'm going to do my molar masses, and all of these are pretty complex, but they are all given above. So you can look at how to get the molar masses, and I'm just going to leave that for you kind of to do with that. Okay, so I got 331 there. I got 150. Let's put a little point there because that was to the nearest gram. And then I got 461 right here. So we will type this in here, 461. And the last one's a little bit hard to see here. It's 85 or 85.0. So I'll call it 85.0 there. Okay, so those are molar masses. We had three, I didn't even go to the nearest tenth on these because they're over 100. And I still have three figures with all these different things. Okay, well, this is the one where I can work with because I know the grams and I know the molar mass, and grams divided by molar mass gives me moles. So that's going to be my place where I'm going to try to work this right here. All right, so I took 69.2 divided by 461. I'm going to get a number less than 1 here. I'm going to do this, and I believe I get 0.15. And if I were trying to be even more precise, it would be 0.150. Okay, now I can work through this mole train to find these other numbers. I know this has a 2 versus a 1 in front here, the implied 1. So 2 is twice as big as 1. So it should be double that. Or if you look at it, I could take 0.15 times 2 over 1, and this should give me 3.0 or 3.00 right here. Okay. This is a 2. So this has 3.00. This is a 2. This should also be a 3.00 right here. So we put that in right there. And then this has a 1 in front, or the implied 1. So that's going to go back to the 1.50. So 1 to 2 to 1 to 2 is the same as 1.5 to 3, 1.5 to 3. Sorry, 0.15 to 3. So kind of messed up my decimals here. It should be 0.300. Let's try this one. Okay, and yeah, I'm gonna have to erase first. Sorry. Oh, here we go. Okay, so I'm gonna erase this one, and yeah, we'll just get rid of that bottom row. So let's try these again. And we will do, this was 0.150. That was a 69 divided by 461. Now I'm going across. 0.15 times 2 over 1 gives me 0.300. And then I look, this is a 2, this is a 2, so they should be the same number. So this is going to be 0.300. And then this is a, like the one here, PBI2, and this are 1-to-1 ratio. So this will be 0.150 right there. And again, 0.300 or 0.300 is the same thing. So I'm not too worried about that. Okay, so now 69 divided by 461 equals 0.15. Going in the other direction, 0.15 times 461 equals 69. So now we multiply up to finish up. 0.3 times 85 ends up being 25.5. 0.3 times 150 ends up being 45.0 right here. And 0.15 times 331 ends up being 49.7. This is a pretty long problem because you got to balance it. You got to do molar masses. It's really kind of a review of a lot of different things. Oh, we can double check our masses to make sure they're okay. Let's look at this and say 49.7 plus 45. I think that's 94.7. So I'm going to add up my reactants, and I'm just going to do that as a double check down here. So I'm going to say, I want to come down here, 49.7 plus 45.0 is supposed to be equal to 69.2, and try this one, plus 25.5. So if you plug those two things in, what do you end up with? I think you're going to find this one's going to be, what, 94.7? So this is like 94.7 right here. On this side, 47 and the 45. And this one ends up being 94.7 as well. So it does match up what we have going on there. Okay. So this would be a pretty long one with some pretty detailed numbers and problem solving and working with that. Just a quick check of this. I'm going to go back to, and your answers I think are here. So you can see all these answers here again for this equation. How does this fit in with the other mole train? Make this just a touch smaller so we can see this and fit it in. Let's look here. Again, let's say we're comparing any two things. Let's say we're comparing these things and these things. We started here, grams divided by moles, divided by molar mass gives me moles. Go through my ratio from here to here would be what? 1 on the bottom, 2 on top. So you go from grams to moles like this, which is sliding across here. And then if you go up moles to grams, you multiply by the molar mass. So this U right here is the same as this U with the mole train turned on its side. All right, thanks for watching. Hope that helps.